All right, we're going to take some of what we've learned and kind of apply it in this lesson. We're going to be talking about angles of elevation and depression, kind of continuing on that prep for physics track. We're going to basically do 3 word problems and then we're going to be through. So let's dive in and take a look. Leah wants to see a castle in an amusement park. Who doesn't? Wouldn't you? She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? So there's a couple of different things going on in here. So when it says they sighted, we're talking about using a device like this where you have something to look through and it's attached to like a protractor and a string is on there with some sort of weight down here. And as you raise this, as you raise up the eyepiece, straw or whatever, there's professional ones as well. This string, of course, will stay straight, but it will move. But since this protractor will be moving, it will move and it'll give you the angle. So that's what we're talking about. She's sitting here and then she's sighting up there and then holding the thing and it's telling her this is the angle of elevation from where she's standing. That's what we're talking about there. And then let's see, is there anything else? How far is she from the nearest foot? Yeah, everything else is pretty obvious. So I have said repeatedly, right, that if you are given a word problem that describes a picture and they don't give you a picture along with it, you should totally sketch that picture, which is a good plan here. So we've got a castle of some sort. There it is. It's great. So cute. Big old tower on the castle and whatever else, right? There's a castle. We've got Leah down here with her little pigtails, and she's looking up at the top of. She's looking to the top and sighting to the top of the castle, right? She sights the top of the castle on an angle of elevation of 38 degrees. So this right here is 38 degrees. She's standing there. 38 degrees. If Leah is 5.5 feet tall, so this distance right here is 5.5 feet. This probably should have actually been like even, but close enough. 5.5 feet tall. And she knows that the castle, because like the wondrous world of whatever, of Wobulus, tells her that it's 190 feet. So from here to here, this distance, this height there, this full height is 190 feet. And we want to know how far is it. So we want to know from here to here, right? That is what we are looking for. So we've got a triangle here. So we need to see if we can figure out the pieces of the puzzle. And then we're going to use our trigonometry, our trig ratios, to find out the length. So let me kind of draw the triangle by itself. Oops. Triangle by itself right there is like this, right? And we know that this angle is 38 degrees. You might say, well, we know that this is 190, but no, that's the importance of she's 5.5 feet tall. This is 190 minus 5.5 feet, right? 190 minus 5.5 would be 184.5 feet. That's how long this length of the triangle is, which is the opposite of 38. We are looking for this one right here, this distance from her to the castle. So we've got opposite and adjacent. Which trig function is that? That's tangent, opposite, adjacent. I don't know, it's kind of weird. O and A, right? So the tangent of 38 degrees is 184.5 over maybe d for distance. That sounds reasonable. Let's solve for d. So we're going to multiply both sides by d. And we're going to end up with d times the tangent. Put that little time symbol there. Tangent of 38 degrees equals 184.5. We've got to get the d by itself, so we're going to divide both sides by the tangent of 38 degrees. Oops, that's not an 8. Clearly not an 8. What's happening? Hello? Restart device reminder. Okay, great. Go away. Why are you bothering me? 38 degrees. And divide this side also by the tangent of 38 degrees. Tangents cancel, leaving us with d equals, and let's go ahead and grab our calculator and we'll do that work right there. So it is 184.5 divided by the tangent of 38. Make sure I'm in degree mode. I am. I covered that in the last lesson. So we're supposed to round to the nearest foot, probably. Yeah. Yes, to the nearest foot. So approximately, d is approximately equal to 236 feet. All right, that's pretty easy peasy, right? And that's how the rest of these are going to go as well. So let's do the next one. All right, a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. Oh no. If the angle of depression, so looking down instead of angle of elevation, looking up, all right, to the other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuer to the person to the nearest foot? So this is actually really kind of similar in a lot of ways, except the triangle's upside down. So let's kind of draw us a picture. So we've got a helicopter. I know it looks just like Susie or Leah or whatever her name was. A little tail on it. I don't know, something. There's a helicopter. Oh, that's like almost a thing. Sort of, kind of, with the feet. I don't know. It's getting more and more exciting. Helicopter. Good enough, right? Pictionary. You guessed it. Maybe make a window. I don't know. Something. There it is. It is, let's see, what do we know? We know that it is 18 feet above the water. So let me kind of get some different colors here. I think that's going to make it easier on this drawing. So it is 18 feet above the water. So from here down to the water is 18 feet. Little feet. Okay. So the angle of depression, so from here, probably more like here, but you know, whatever, down to the person is 42 degrees. Whoosh, there's the water. 18 feet, 42 degrees. All right, so there, drop down, 90-degree angle, 18 feet above the water. What is the horizontal distance? So we want to know how far to save the dude that is kind of dying. Oh no, oh, I'm drowning, save me with my little hand, help me. Something, I don't know. Whatever's happening there. We're looking for this distance. We know the adjacent, and we're looking for the opposite. We still have OR, right? Opposite and adjacent, so we're still using tangent. We're just doing it slightly. It's just going to be a slightly different thing. So it is the tangent of 42 degrees. The tangent of 42 degrees, 42 degrees, equals the opposite, so we'll use d for distance again, over the adjacent, which is 18. Now, this one's even more simple and straightforward. Just multiply both sides by 18, and then we can pop that in the calculator. So the distance equals 18 times the tangent of 42. So 18 times the tangent of 42 equals 16, round to the nearest foot, so 16 feet. So approximately equal to 16 feet. No big deal. We've got one more. This last one, we save the best for last. This next one's got all kinds of things happening. It's a fun one. Let's dive right into it. Oop. Hello. Okay, there we go. Oops. You visible right there. Great. We did it. To estimate the height of a tree she wants to remove, Mrs. Long sights the tree's top at a 70-degree angle of elevation. She then steps back 10 meters and sights the top at 26-degree angle. If Mrs. Long's line of sight is 1.7 meters above the ground, how tall is the tree to the nearest meter? So we got all kinds of things going on. So we've got this big old tree. Let's see. We've got a green in this theme here. Yeah, that's great. I got a green, you got a green. There's a big old tree, real tall tree. There it is. Isn't it cute? So we've got Mrs. Long, who is standing close to the tree from here to here, and she sights a 70-degree angle. So from here up to the top of the tree is a 70-degree angle. So 70 degrees. Then she steps back 10 meters. So she was here and she goes back 10 meters. So this distance, let's do a different color for clarity's sake. So from here to here is 10 meters. 10 meters. So this distance is 10 meters, right? And she sights the top at 26-degree angle. So from here to the top is 26. So this is 26 degrees. If Mrs. Long's line of sight is 1.7 meters, so the tree is actually like this tall, and this height from her height to right to the floor, so right there, is 1.7 meters. 1.7 meters. All right. And so now we need to figure out how tall the tree is. So we're looking for, kind of clean up my triangle right there. We are looking for, let's do it even in a different color. We'll do it, in a little bit bolder. We're looking for this right here. How tall the tree is. That is what we are looking for, right? Okay, so there's all kinds of things happening on this one, right? So we've got this length that is ultimately look for. We're gonna let's label this as H for height. That sounds reasonable. Okay, so that's what we're looking for, right? That is totally what's needed right there. Now we also have kind of another unknown happening. So we're ultimately probably going to have to use a system, right? Probably. We'll kind of guess our way through because we don't know how close she was standing to begin with either, right? So we don't know this distance, right? So we've kind of got two different triangles happening here. So I'm going to kind of draw the two triangles a little bit separately, so that way it's going to be easier to kind of figure out what's happening here. So I don't want that big. I want it down, wrong direction. I want it down like pretty small. There we go. So this and this, we've got this one with 26 degrees, and its distance for this one is 10 plus x, right? And then this distance right here is our h. It's our h. It's actually h plus 1.7, right? So h, so h, if it's 8, because h is this height right here, because we're going to find out her height. We're going to find, using these two triangles, we're going to find it out, and then we need to add in that 1.7 meters of her height. So we'll call this h, but let's remember that we need to add that 1.7 at the end. I think that's going to be the easiest way to go about it. So this height is h. Now then we've also got this other triangle, which is a kind of much smaller triangle, right? She's a lot closer to the tree, and it's 70 degrees, and it has this length down here of a side of x, and then the height of h. Now remember, in the end, we're going to find h, and then we're going to have to add that 1.7 to it in order to do this. So we have two variables, which means we need two equations. I think I want to take, I don't know if I'm going to be able to do it very well. I think I'm gonna, for the sake of, no, I don't want to do that. This is too high up here. I think if I try to move this, let me pause it and figure this out, and then I'll be right back. Okay, so I needed that to be smaller, but I didn't want to erase it because that's going to help us remember to do the 1.7. So I had to do a little finagling, moving things, but there we go. Now we're good to go. We're back to what we need to be doing. So let's see if we can find a couple of different equations, because we need two equations because we have two variables, right? So we're going to have to solve a system. And it's going to be a system with trig functions. Oh no, it's going to be okay. It's going to be okay. Don't stress. So let's first start and figure out what trig function we're going to look at with these things. So with this triangle, we've got opposite and adjacent. So tangent. On this triangle, we've got opposite and adjacent. So we've got tangent again. So let's set up a trig ratio for this first triangle over here. We'll let our colors match what we did here. So let's do this in purple. So the tangent, not time, but tangent of 26 degrees equals opposite, so h, over adjacent, so 10 plus x. Great. So this triangle, which I'll do in green because that's this one over here, is the tangent of 70 degrees equals the opposite, so that's h, over the adjacent, which is x. All right, so now what could we do? Well, let's take a look at what we got going on here. We've got these two things, and if we go ahead and get these denominators out, then both of them are going to be equal to h, right? Which is going to be helpful because then we can substitute one for the other. So let's multiply both sides by 10 plus x over here. 10 plus x on this one, and then we're going to do the same thing. Oh, I don't know why I'm doing, I was thinking that it reminded me of the conjugate and whatever, which we've been learning about in algebra 2, and so I started not doing the conjugate, but something like it. I don't know. This is going to cancel, and then we're going to multiply it on this other side. Now you notice I put it in parentheses. That's to help us remember that we'd have to distribute this if we were going to do something with it. Path selection tool, great. So these cancel, leaving us with h equals, for this purple one, h equals, I'm not going to distribute it yet. I'm going to wait. Sometimes it's helpful to wait to distribute it because stuff may cancel or whatever else. So 10 plus x times the tangent of 26 degrees, right? So this one is even simpler, right? Because we just got to multiply times x on both sides, so times x and times x. These cancel. So over here we have h equals x times the tangent of 70 degrees, right? So this equals h and this equals h, so we can set them equal to each other. We're just substituting one for the other, right? We've done a lot of that, really. So I do think before I do that I do want to go ahead and distribute this, and you'll see why in a second. So let's go ahead and take care of that real quick. Multiply this and multiply that, and do this as h equals 10 times the tangent of 26 plus x times the tangent of 26. You might be thinking, well, how do I know to do that? Well, you don't, and either distribute it now or distribute it later. It'll come up as you need to do it, right? So you don't necessarily have forethought yet, right? So this equals h and this equals h. So we're going to set the two equal to each other. So 10, all this mess, not plus, that's a tangent. So 10 times the tangent of 26 degrees plus x times the tangent of 26 degrees equals x times the tangent of 70 degrees. right? So what might we do next? Well, we probably should get the terms that have the x's on them together, right? Because we need to get, we're solving for x so far, and we're going to substitute that back in and get h here in a second. But we need to get x, right? So we should get the x's together. So let's do that. So we're going to subtract both sides. Let's do a totally different color. By x times the tangent of 26 degrees. Oops. Then minus x times the tangent of 26 degrees. We can't quite combine these yet. We're going to deal with that in a second. So this all cancels, leaving us with, let me pause and move some stuff around. All right, we're back. So this is, I'm going to do this line on this this level. No, I'm going to do what I thought I was going to do. We're going to move this up to here. So 10 times the tangent of 26 degrees equals x times the tangent of 70 degrees minus x times the tangent of 26 degrees, right? That's just this minus this over there, and this brought down, right? That's what that was. So on the right side, both of these have x's in them, so we can factor out an x, right? We're in second semester, so we're hitting the second semester Algebra 1 stuff too, right? So we're pulling a GCF out of the right-hand side. So 10 times the tangent of 26 degrees equals x. We're pulling an x out, right? And then we put in parentheses. So remember when we factor out a GCF, we put out the GCF on the outside, and then on the inside, it's each term divided by that GCF. So this divided by x, the x parts cancel, leaving us with the tangent of 70 degrees minus the tangent of 26 degrees. Right? Now, how can we get rid of all this mess? Well, we could divide it all on both sides. So we're going to divide both sides by that. I'm going to, for the sake of space, just say we're dividing everything by the tangent of 70 degrees minus the tangent of 26 degrees. So it cancels on this side, leaving us with just x. So x equals 10 times the tangent of 26 degrees over the tangent of 70 degrees minus the tangent of 26 degrees. So all that equals x. We could go ahead and we could totally get a decimal equivalent for this now, and that wouldn't necessarily be a problem at all. We could have actually probably done that sooner and done with decimals and whatever. I just like to wait because A, it's good practice for later, and B, it gives us a more accurate and exact answer as our final answer. And also, so I'm not gonna like punch this in yet because h is just x, which is all this, times the tangent of 70 degrees. So to get h, I just do this times the tangent of 70 degrees. So h equals all of this, 10 times the tangent of 26 degrees over the tangent of 70 degrees minus the tangent of 26 degrees times the tangent of 70 degrees. And that's just plugging all of this in right here, right? That's all we're doing. Tangent of 70 degrees. Now we're going to start punching stuff in the calculator. So let's do it. Let's get some decimal equivalent. Y'all are probably looking at all this thinking, yeah, devil's right. That's right. Let's just throw this. That's where we should put this. No, stop it. You're doing fine. It's going to be okay. Just breathe. Let's grab our calculator. Find the tangent of 70 degrees. Enter. So the tangent of 70 degrees is 2.747. So I'm going to write this with decimals in there. So h equals 10 times 2.747. No, that's not right. That's tangent of 26 degrees. Leave that in my calculator. Tangent of 26 degrees is 0.488. So times 0.488 over the tangent of 70 degrees, which was 2.4747. 2.747 minus 0.488, and then times tangent of 70, which was this one, right? Tangent of 70, nope, 2.747. Glad I checked. Makes sense. I don't know what my brain was thinking. Sometimes it doesn't do that well, especially when you're making videos. All right, so 10 times that is easy peasy. 10 times that would be 4.88 divided by this minus that one equals 2.260. 2.260, right? Rounding, yes, great. All of that times 2.747. So let's punch that in the thing. Let's go up here and grab this. I'm going to get this in my calculator. That times 10, great. Oh, except I hit times 11. That times 10 equals that. So that divided by 2 point, this one. What is it doing? What is happening? I was trying to be clever, and let me pause, and somehow I accidentally stuck answer or something. I don't know. So let's not be quite so clever and just do 4.88 divided by 2.26 equals that times 2.747 equals that. So H equals 5.9315. 5.932 is approximately equal to 5.932. So that is the H that we found, and in order to get the actual H, we got to add that to 1.7, which is her eye level, plus 1.7 equals. So the tree is, and we're supposed to do to the nearest meter, so approximately 8 meters. So about, what is that? 8 meters. And that is all she wrote. Not too bad. This is a crazy example. You're not likely to find an example this, or a problem this difficult on a test or a quiz, but it's a great example problem, and it would make a pretty decent homework problem. I will see y'all in the next one. Like, comment, subscribe, all the things. Goodbye. See you later. Bye-bye.